So I think we'll just get started. I think I will start by saying happy World PH Day. So actually today it's the 7th and the actual day is on the 5th. But we know that a lot of associations have events going on in all of May. And it's important to remember why we mark this day, because on May 5th, there was a little boy that died in Spain of PH, and it was during this toxic rapeseed oil scandal. And one of our Spanish associations, the ANHP, they had this idea about marking this day, World PH Day, and they did so in 2012. And I would like to give a big thank you to them. And then the year after, PHI Europe took over, and we continue this tradition. And now World PH Day is celebrated actually all over the world, and we have patient associations in all the corners of the world marking this day. And it's very nice today to be able to welcome you all, because I think we're going to have a very interesting and good webinar. We have 3 experts with us here today, and I'm going to make it very simple for myself. So I'm going to ask them to introduce themselves, and maybe we can do it by the order of the photos on the invitation. So Dr. Simon Clark, can we maybe start with you?
Sure thing. Hi. I suppose it's good evening for me here in the UK, everyone. My name is Dr. Simon Clark, and I am a full-time climate communicator and recovering academic. I did research and got my PhD in atmospheric science before starting to talk about climate to the public, and I've been doing that for the past 7 or 8 years now.
Great. Welcome. And Dr. Mona Lichtblau?
Welcome, everyone, and thank you, Hall, for inviting all of us to this World PH Day session. Myself, I'm a physician. I work in the Pulmonary Hypertension Center at the University Hospital in Zurich in Switzerland. And since I started medicine, this has been my field of interest and passion. I'm just happy to be here today.
And then Dr. Lucilla Piccari?
Yes. Hello, everybody. Thank you for joining us to this webinar, which is we organized with the kind hosting of Hall and the old PHA Europe. My name is Lucilla Piccari, and I work as a pulmonologist in Barcelona at Hospital del Mar. And I'm a research physician, and I specialize in pH, and especially in pH associated with lung disease. And I'm very happy to be here with you today.
Well, thank you so much for all 3 of you to agreeing to be part of this. So what we will do is we will divide this into 3 sections. And the first section, we will talk about climate change. Second session, we will talk about pH and how the climate change affect pH patients. And then the third section, we will have a Q&A session. So once the presentations get started and maybe you have some questions, please use the field to the left, conversation field to the left, and write your questions. And then we will cover them in the third segment, the last Q&A session. So I think we will just get started.
Thank you, Hal. I will take the helm for this first section. And fundamentally, the most basic question is, what is climate change? And to answer that, we first need to know what climate is. Climate refers to the long-term average of weather. The World Meteorological Organization refers to climate as the 30-year average of weather at a given location. So that means the average temperature over those 30 years, but also the average amount of rainfall, the average amount of days of heat wave or drought. And we can do that for individual places like the UK or Spain or Switzerland, but we can also do it for the entire planet. And climate change refers to the fact that the planet's average climate has been shifting. Most notably, the planet's average temperature has been increasing. Last year, it was 1.5 degrees warmer, 1.5 degrees Celsius warmer than what we call pre-industrial, so before the Industrial Revolution, practically before about 1750. But climate change is not just about temperature rise. We refer to global warming, but we also, within climate change, talk about other parameters changing. For example, we talk about changes in rainfall. That's what that top set of figures is referring to. But other changes, such as change in soil moisture, which has massive implications for growing food in agriculture. And what you'll notice here is that these are simulated changes at different levels of global warming. Within climate science, we tend to peg the results of climate change at different levels of warming because it's a nice, easy number that people can get a basic hold of to refer to roughly how much the planet has warmed by. And what you can see is that as the planet warms, these impacts in other areas also grow, just as the temperature anomaly grows. So the simulated change of 1.5 degrees warming in terms of precipitation change is much less than the simulated precipitation change at 4 degrees of warming. You'll see that at 4 degrees, Western Europe is significantly drier, whilst the Indian subcontinent is significantly wetter. And this, if you ask me what is climate change, is ultimately because the amount of energy in the Earth system is increasing. We are trapping more energy in the Earth system than is leaving to space. And it's a very reasonable question to ask, why is that happening? And we are very confident that humans are responsible for this change. Why are we so confident that humans are responsible for this change? Well, there are a couple of lines of evidence. The main one is that the principal control on global average temperature over the Earth's history has been the level of carbon dioxide in the atmosphere. We can reconstruct past temperatures through various means, including looking at tree rings, through looking at ice cores in Antarctica, but also more esoteric things like coral reefs and records left behind in caves. And we can see how temperatures have changed over time. And we can also see how CO2 levels have changed over time. And we see that there is a very tight correlation between the two. When CO2 levels go up, temperatures go up. And over the past couple of thousand years, this is what the CO2 level in the atmosphere has looked like. We can see that it varies and wiggles over time, but in the past couple of centuries, it has skyrocketed. It has gone from about 280 parts per million to 420. I think the current figure is 425 parts per million, and it's increasing by a few parts per million every year. Now, most people would look at this graph and say that that's pretty clear evidence that something unnatural is happening. It's probably humans. But we can do better than this. One of my favorite pieces of evidence when it comes to climate change is this next graph. So what this is showing is the ratio of carbon-13 in the atmosphere. So most carbon in the atmosphere, like most carbon in the entire world, is carbon-12, but you get certain radioactive isotopes of carbon, carbon-13 and 14. If you've ever heard of carbon dating, this is the kind of carbon that's used in that. The way that that dating works is that an object that is created out of, for example, wood, has a certain fraction of carbon-12, 13 and 14 in it when it's created. But the amount of carbon-13 and 14 decay over time because they're radioactive. Those atoms of carbon decay into other things. And what we see in this figure is that the average amount of carbon-13 in the atmosphere has been decreasing. And that tells us that all that extra carbon that has been going into the atmosphere must come from a very ancient source because all the carbon-13 in it has disappeared. And so it's dragging down the average. The carbon that we're adding to the atmosphere is ancient because it comes from fossil fuels that we are burning. It comes from coal and oil and gas. It's very clear evidence that the extra carbon in the atmosphere is there because of human activities and not because of, for example, volcanoes or other tectonic activity. So between this and other pieces of evidence, we are very sure that humans are responsible. Now, I've just mentioned burning fossil fuels, and that is absolutely the main cause of climate change. But it's not the only cause. We tend to break down the emissions of carbon dioxide into those from burning fossil fuels for energy and the emission of carbon through land use change. So this refers to principally deforestation and agriculture. And what you can see at the moment is that about 90% of carbon emissions come from the burning of fossil fuels, and the remaining 10% come from land use change. And for the largest time since the start of the Industrial Revolution, those processes were roughly the same. But in the past couple of decades, we've seen that our emissions due to fossil fuel usage have just exploded. And this is something that continues to rise year on year, though we will come back to that in just a couple of slides. So I've already sort of talked about the average when it comes to climate change, the average temperature change, the average precipitation change. But we also know that there is a relationship between climate change and extreme weather events, meaning extreme temperatures, both high and low temperatures, but also extreme weather events like hurricanes, flooding, drought, all of these kinds of things. And we know that as the planet continues to warm, these extremes will become more extreme, meaning for temperature, for example, the temperatures will get higher and higher. But we also know that they will become more frequent. So what you can see in this figure, this is from the IPCC's latest report, that an event that might happen once every 10 years in a world that didn't have any climate change would occur 2.8 times more frequently in our world today, and would occur almost 10 times more frequently if the average temperature increased by 4 degrees. And the same applies for 50-year events or 100-year events. Events that previously would be seen once every couple of centuries, we could see every couple of decades in a warmed planet. And it's not just for increased temperatures, we also see this for flooding events, heavy precipitation, but also droughts. And this has massive knock-on effects with various sectors, most notably perhaps agriculture. If you're seeing extreme droughts and extreme heat waves, that's going to impact your ability to grow food and also to keep the biosphere alive. It's not one of the questions that I was going to answer today, but the answer to the question, how serious is climate change, is extremely serious. At the moment, our best guess of how climate policies will affect our temperature change this century is that we'll warm by 2.7 degrees Celsius by the year 2100. That is a lot lower than we originally feared. Originally, scientists feared that we may be looking at 5 or 6 degrees, and that would have been kind of game over, really. That would have been really the end of life as we know it. 2.7 degrees is still bad, but it is not that bad. Really, we want to get warming below 2 degrees. That's partly because it's a nice round number and it's easy to shoot for, but it's also because there are many climate systems, what we call tipping points, that if the planet warms by more than 2 degrees, we are pretty confident would be triggered. Most notably, a large amount of sea level rise. 2 degrees was historically chosen because if Greenland were to melt, which we think it would at 2 degrees, that would raise the sea level by several meters, maybe as much as 10 meters over the course of a few hundred or thousand years. And that's not really a scenario that anybody wanted. So that's why we tend to say 2 degrees is the threshold that we're happy with. And at the moment, we are not close to hitting that threshold. But is there any hope? Is it too late to stop this problem? The answer is definitely no, it's not too late. And the reason for that is there is a very clear linear relationship between the amount of carbon we put in the atmosphere and how much climate change, how much warming we see. Or in other words, if we stop putting carbon into the atmosphere, we stop warming the planet. So these different curves, the different colors here, represent possible pathways into the 21st century and how much extra carbon we put in. And what you'll see is that if you, on the bottom axis, you've got cumulative carbon emissions, the total amount of carbon put into the atmosphere. And on the vertical axis, you've got the warming that we experience. And as soon as you stop putting carbon into the atmosphere, you stop warming the planet. So it's as simple as stopping burning fossil fuels and preventing deforestation and managing the land in a way that doesn't add carbon to the atmosphere. Very simple to say, very difficult to do, but the world is making enormous progress. I actually made a YouTube video about this recently. Land use emissions have decreased by 30% since the year 2000. Deforestation in the Amazon has halved in the past couple of years. So on that side of things, we're making very promising progress. And emissions due to energy use have kind of plateaued over the past couple of years. And the data at the moment indicates that China may have hit its turning point and its emissions might now start to fall. We may be looking at peak global emissions in the next year or two. And it may have already happened, but it takes a while to work out. So we are very much moving in the right direction. It's just a question of how quickly we can do that. The principal way that we're going to get to net zero and not putting more carbon into the atmosphere is by not burning fossil fuels and instead getting our energy through other sources, notably renewable electricity, and electrifying our systems. That's something that can take place across transport, across heating, industrial processes. It kind of needs to be the entire economy. And that is what we are doing. And there are a great many people who are working very hard to make that possible. And yes, still quite a few people who are working very hard to stop it from happening, including the new president of the White House. But overall, the world is still moving in the right direction. And that's because it now makes economic sense to. These technologies that are cleaner have become so cost competitive that it just makes sense to start using them. And my personal prediction is that in the next the next decade, you're going to see some really rapid changes start to happen. So the situation is not hopeless. It is very much serious, but there is still something that we can do. Now, to try and do a handover to the other part of this presentation, I wanted to ask, what is the link between climate change and public healthcare? Because so far I've talked about the physical climate system because that's my background. I'm a physicist. But there are many ways in which climate change impacts our ability to deliver public healthcare. Starting at the top here, we know that we're seeing increasing heat extremes, both the temperature of heat waves, but also how frequently they occur. But to the left of that, we also see increasing humidity. As air warms, it can hold more moisture. And what we've seen over the past couple of decades is that the average humidity around the world has started to climb up. And when you combine that with extreme temperature events, we see a huge amount of heat stress being put on the human body. In particular, in places like the Indian subcontinent, we're starting to see the wet bulb temperature, which is the lowest temperature that an object can reach through evaporating water. So that basically means the coolest that a human can cool themselves to. We're starting to see that temperature approach 36.5 degrees at times of the year in India and Bangladesh and Pakistan. And when that occurs over long periods of time, the human body cannot cool itself to a point where it maintains homeostasis. And that is fatal over long periods of time. We're starting to see this creep up. But even when we're not approaching that threshold, those two factors together, increasing heat stress on the body, exacerbates many other conditions, and especially cardiovascular conditions. So that is a significant impact on public healthcare. The increasing humidity and changing precipitation patterns, as I've already mentioned, will lead to changing patterns of agriculture and how well we are able to feed the planet. Nutrition is going to become an increasing problem, especially as the world population continues to grow and as the world middle class continues to grow, and we expect more protein in our diet. We're going to start to see malnutrition becoming more and more common, and that's going to be an additional healthcare burden. Working our way around anti-clockwise, the mental health burden of climate change is often ignored, but a really serious impact, both in terms of watching everything else that's unfolding in terms of food insecurity, in terms of knowing that you have more heat waves to deal with, but also dealing with a future that you cannot be sure will be better than the world you inherited. And that's a really significant mental health challenge that will also strain healthcare provision. I'll skip over particulate matter for just a second. The financial burden of climate change means that as climate change becomes more and more expensive, less and less funding will become available for healthcare provision, and that is going to reduce the quality of care that we experience. And there is also expected to be an increase in the extreme cold events. This was something that my thesis looked at, actually, but especially in the mid-latitudes in the Northern Hemisphere, we can expect to see more extreme cold outbreaks. And that, combined with the increase in extreme heat, is causing diseases especially tropical diseases, to shift where they are thriving. And we're starting to see diseases from, for example, Northern Africa migrate into Europe. And that poses a particular challenge to healthcare provision because we're not trained for this we don't have the experts for this kind of healthcare in, for example, Europe. That last point that I wanted to come back to, particulate matter. So this is something that I understand Lucilla and Mono are going to talk about a bit more in their presentation. But the principal cause of climate change is burning fossil fuels. And burning fossil fuels also adds an enormous amount of particulate matter, meaning really small particles, into the air. And it was estimated by the Lancet before the last COP event that the burning of fossil fuels for energy causes an estimated 5 million excess deaths per year. And that's through the particulate matter from, for example, burning coal in particular, entering the bloodstream, and that causing any number of conditions and exacerbating pulmonary and cardiovascular conditions. So whilst it is not explicitly caused by climate change, it is something, it is almost a comorbidity, if you like. It's impacting our climate, but it is also impacting our health. But this is definitely something that is outside of my expertise, and so I will yield the floor to my two colleagues here to talk more about the link between climate change and public health and pulmonary hypertension specifically.
Well, thank you, Simon, for this excellent presentation. And I was just want to remind everyone, if you have any questions, please write them in the conversation field. And then we will get back to them at the last segment. So now we will move into the pH world. We will see how climate change affects people with pH, and how maybe it affects access to healthcare, and what can we do as pH patients to protect ourselves in our daily life, and what role does the healthcare workers play, and what about the patient associations? So I think the floor is yours, Lucilla.
Thank you so much. It's an honor to be here with you guys. So first, a brief introduction on pulmonary hypertension. What is pulmonary hypertension? It is increased pressure in the circulation inside the lungs, so in the blood vessels of the lungs. And it's classified in 5 groups. And I'm just going to go over them very quickly because we're going to mention them during the presentation. Group 1 is when the arteries of the lungs have a disease, a primary disease. And this can be isolated, and in that case, it's called idiopathic, or it can be associated with a number of other diseases. Group 2 is when there is a problem in a valve in the heart or in the left side of the heart, which is a very common occurrence. And in that case, the pulmonary circulation, which sits behind the left part of the heart, is affected as a result. Group 3 is when there is another pulmonary disease like emphysema, chronic obstructive pulmonary disease, or pulmonary fibrosis. Group 4 is when there was a pulmonary embolism in the past, and there is a blood clot that has lodged itself from somewhere else in the body in the lungs, and it stays there for a long time, and it becomes a chronic obstruction. It kind of sits inside the blood vessels, and it creates a chronic obstruction that creates the increased pressure. And group 5 is kind of a miscellaneous of a number of different diseases that are associated with pulmonary hypertension for somewhat mysterious reasons that we haven't really figured out yet. It is important to notice that group 1 and group 4 are rare diseases. They're also the ones that are the forms that are most studied in pulmonary hypertension, and there is treatment for these forms. Group 2 and 3 are the most common ones, in particular group 2 is the most common one. Also, I want to point out that we are going to refer to some scientific work in the bottom part of the slides in this presentation. If you want to receive these works, please do get in touch. We're very happy to share them with you so you can read more about this. So how does climate change impact people living with pulmonary hypertension? As we heard very well in the presentation by Dr. Clark, climate change can increase the risk of extreme weather events. And in particular, there are studies that look at heat waves, and patients who have pulmonary arterial hypertension, which is the first group that I mentioned before, the one where the arteries are diseased. These patients have an increase in symptoms and a decrease in physical activity during heat waves. And also, there is an increase in the frequency of how many times the PAH and chronic thromboembolic pulmonary disease, the group 4, the one after pulmonary embolism, and heart failure are diagnosed during a heat wave. So there is an increased frequency of diagnosis. When pulmonary hypertension is associated with heart failure, it is demonstrated that the body cannot adapt as well to heat. And this is kind of what was Dr. Clark was saying just before, that the body has difficulty during heart failure to adapt. So these patients are particularly vulnerable to heat. In the case of both heat waves and cold spells, there is an increase in symptoms in patients who have a dilated heart, a condition that is called dilated cardiomyopathy, but also an increase of frequency of heart disease that cause PH, so diseases that are associated with PH. For instance, congenital heart defects, these are babies that are born with something different in their heart, which causes a disease, and a reduced heart function after a heart attack. Heart attacks or acute myocardial infarction are one of the most common cardiovascular diseases and one of the biggest killers in the world. And how the heart functions after a heart attack is reduced during a heat wave or a cold spell. There is also, during heat waves, cold spells, and also dust storms, an increase in the symptoms, the frequency of acute exacerbations, so an acute worsening of the disease, hospitalizations, and even risk of death in patients who have chronic obstructive pulmonary disease or emphysema. So this is a big risk factor for these patients. And now I hand over to my colleague, Dr. Mona Lichtblau.
So now we come to another part that might influence not only the life of the patients with PH, but everyone. And this is the rise in sea level, which Dr. Clark already alluded to. We copied a small map here into the slide, and you can check it for yourself on the web page that is put into here. But you see that already as early as 2030, we expect major sea level rises that impact coastal lines around the world. And the question is, what can people do that are affected by those sea level rises beside building dams? They might be in need to move, and you could relocate to a higher altitude. When looking at high altitude, this means levels above sea of 2,000 meters or 2,500 meters and higher. We know that this can impact the health. We know that at high altitude, the barometric pressure decreases, and thus the availability of oxygen in the air decreases. And even in healthy, this causes an increase in the pulmonary pressure due to an effect we call hypoxic pulmonary vasoconstrictions. So the low oxygen in the air causes all the vessels in the lung to shrink, and this increases the pressure in the lung. And this can lead to symptoms. We also know that people living at high altitude can develop the disease called high altitude pulmonary hypertension. And this is one of the subgroups in the group 3 pulmonary hypertension. But we also know that we have lots of patients with PAH or group 1 PH that live at high altitude. So what the effect of altitude on patients with PAH actually is, we don't know. But this is something that we need to consider in a world facing climate change. Next, and this is something that Dr. Clark already also alluded to, is that we have a change in infectious diseases with the increase in average global temperatures. One of those infectious diseases is caused by a blood parasite. It's called schistosomiasis. And this might, like global change, might cause an increase in the parasite in regions that are not affected yet. And schistosomiasis can cause PAH, and we call this group schistosomiasis PAH. And it's actually the most common form of PAH worldwide. So this is something that we should definitely keep in mind. We have no proof yet that we will actually see more schistosomiasis PAH, but we will know the answer in several years. Also, Dr. Clark already alluded to problems with food production that might lead to human displacement. So we will have climate change refugees, and they might be more prone to transmitting infectious diseases because they do not have access to care, they do not have access to their medications. And so we might see an increase in, for example, tuberculosis And we know that tuberculosis can cause post-tuberculosis lung disease-associated pulmonary hypertension, but we might also see an increase in HIV and HIV-related PAH, as well as certain liver diseases that are associated with viruses, and they might lead to portopulmonary pulmonary arterial hypertension, which is group 1 pulmonary hypertension. So this is something that all of the physicians treating patients with PH need to be or have in mind in the future, because they might see different forms of PH in their field which they have not seen in the past. Now I hand back over to Lucilla that will cover a little bit more about the environmental pollution.
Yes, thank you, Mona. So we heard already about particulate matter. So air pollution is caused by a number of components that come into the air and that we breathe. And in particular, it has been shown that coarser and bigger particulate matter in the air, which is part of air pollution, can cause inflammation in the lungs. Patients can inhale this and it will sit in the lung and it will cause inflammation, particularly through reactive oxygen species that will basically cause a state of chronic inflammation. When the particulate matter is very small, such as PM 2.5, this can actually go from the air spaces to the blood vessels from the lung. And from there, they enter the circulation and they can do damage both locally in the pulmonary vessels, so pulmonary vascular disease by definition, and then they can travel to different organs. And as Dr. Clark was mentioning, they're being linked to increase of the incidence of stroke or increase in cardiovascular disease. So this is a particularly dangerous situation. As we have researched this topic, we have seen that there is an increased pulmonary pressure and inflammation in general in their whole body in children who are exposed to higher levels of air pollution. There is an increase in the frequency and severity of PH diagnosis, and there is an increased risk of death in patients who have pulmonary arterial hypertension. It is also, air pollution, the main cause of COPD, of chronic obstructive pulmonary disease, in patients who have never smoked. This has become a major concern worldwide because chronic obstructive pulmonary disease is a very prevalent disease. And it accounts, probably air pollution accounts for as much as 8% of deaths in patients who have chronic obstructive pulmonary disease. So it is one of the factors that is driving emphysema and lung disease worldwide. There is an increase in the frequency and severity of pulmonary fibrosis, which is a particularly severe diagnosis, lung diagnosis. And there is an increase in the severity and risk of death of chronic thromboembolic pulmonary hypertension. So all of these conditions are affected by an increased level of air pollution. And I hand over to Mona again.
So when we talk about pollution, we do not only talk about air pollution, but also soil or water pollution by, for example, chemical products that are used in industry. And you just see in the picture some of the examples that we're talking about, but there is clear evidence that these chemical pollutions increase the risk of development of autoimmune diseases, such as, for example, scleroderma. And we all know that scleroderma is closely linked to pulmonary hypertension, but also, for example, for pulmonary veno-occlusive disease, which is a very rare form of pulmonary hypertension. Furthermore, we know that these chemical products, they can increase the risk of having a congenital heart disease, so a heart defect in newborns. And so we just thought we wanted to include this as well, because climate change is not only about air pollution, it's really about humans polluting the earth. And this is why we included some of the information here. Now, to summarize all of this, we have designed this graph, and you can find it in this publication by Lucilla and me, and this is open access, so everybody can go and download this publication. And this tree, you need to read it from the bottom, so from the roots of the tree to the leaves of the tree. And you can see here what Simon already talked about, that intensive farming, but also the petrochemical production and fossil fuels burning causes climate change and pollution. And all of this leads to the consequence of biodiversity loss, shortages, disruption of healthcare infrastructure, and so on. And we just summarized on this graph all the evidence that we have that could affect patients with PH in the various groups. So you see all patients with PH, no matter which group they have, can be impacted by climate change and air pollution. Without going into all the details, but if you're very interested in the topic, we are happy to share this publication with you. Now, coming to our next topic, does climate change actually affect the access to healthcare for patients with PH? Obviously, in the field of PH, we do not have the studies that prove this point, but it's easy to understand that if you have a flood or an extreme weather event where you cannot come to the hospital or the medication might not be delivered or produced, that there will be severe problems with access to healthcare, not only physical, being able to travel to the patients or the patients coming to the doctor, but there might also be a disruption of provision of medications, such as the very complex medications that patients with PH receive, or oxygen therapy. And Simon Clark also alluded to the fact that climate change actually has mental consequences. And one of the questions that Hall asked us was like, is there evidence that climate-related stress affects the mental health of people with PH? And we don't know, so maybe you have the answer for us. But I could easily think that the answer to this question is a yes. And with this, I hand back over to Lucilla.
So we also wanted to go over what people living with PH do to adapt to a changing climate. So in general, you probably have heard recommendations for what to do during extreme heat. And so you can see here in this graph, for instance, from a publication on the New England Journal of Medicine, that there are individual level protections and population level protections. And so at the individual level, of course, hydration, use loose-fitting clothing, and try to avoid going out in extreme heat. But most importantly, I would say at the population level protection, you should be checking systems for the vulnerable populations and build environment to address the urban heat island effect, among many others. In our research, we have looked at what people with PH in particular can do. And so at the individual level, we divided some of the evidence that we found into adaptation, mitigation, and prevention. And so some of the evidence that exists points out to using masks during severe air pollution, such as, for instance, when the air is more polluted because there is like the weather favors higher pollution concentration, but also when there is a wildfire event near your house. Also the use of indoor air filtering devices. Then other recommendations could be to have a healthy lifestyle, and as much as possible, even though patients with PH can have reduced exercise tolerance, have an active life as much as possible. But I would say that the focus of our recommendations are more on the healthcare system and on the general community, because there is only so much that an individual can do to protect themselves for such a very systemic situation. So at the level of the healthcare system, there are definitely a number of measures that can be adopted, such as alert systems, the use of electronic health, so video visits and phone calls to check in on patients and give recommendations, and also telemonitoring through devices. Definitely a reinforcement of healthcare structures to be able to withstand extreme weather events. And as healthcare workers, we think that we need to advocate for sustainable policies, hopefully reduce the carbon footprint of medical care, which is at the moment is very high. And in all of this, obviously, we need to educate patients and carers and the general community on the risks of climate change to public health. At the level of the general community, there is a lot to be done in urban planning to provide temperature shelters, and obviously upkeep of the public infrastructure, the natural landscaping in the urban environment to avoid that heat island effect that I was talking about before. Definitely pest and infections control is a very important part, but also providing feasible and affordable public transport in order to reduce carbon emission and favor renewable energies, as Dr. Clark was mentioning before, and a sustainable waste disposal for the communities. So all of these are measures that can be taken. And again, there are some individual measures that can be taken, but the most impactful measures should be taken and will be taken at the level of the community. So I hand over back to Mona.
Yeah, I have the honor to do the conclusions. So we've talked about the evidence that we have on climate change and environmental pollution affecting patients with PH. We also have looked at diseases that are associated with PH and the effect of climate change on those diseases. We know that healthcare for patients with PH is very complex. It requires a network of care with several healthcare practitioners participating, and this can be disrupted by climate change induced weather events. And we do need policies that protect and support people with PH and everybody else that face environmental threats. Now we come to the last slide of our presentation, and Lucilla and I, we created a survey where we wanted to know if you as a patient are actually affected by pollution and climate change. Is this something that you think about? Does it feel like it matters to you? And we would be very happy if you could participate. You can access the questionnaire with the QR code, or you can enter the web link directly. And today it's only available in English, but we will put several translations in the most common languages for your provision. And we will be very happy if you could share it with your PH community to hear what you think about this topic. And with this, I hand back to Hall.
Well, thank you so much. That was very interesting. So I think we're doing quite well on time, and people are being very shy because there is not much questions here. But I have written down a few, so I can certainly ask some. But I just want to add that I will send out an email to the PHI Europe community with the QR code, and we will try to get as many as possible to participate in this survey, which I think will be very interesting. So maybe I could ask some questions to Dr. Clark. So when I've talked to people about climate change, then some people say that this is just normal variations. Like if you go back thousands of years, the globe was warmer, and then it was cool periods and warm periods. And they say what we have today is just a normal variation.
Yeah, it's absolutely true that the Earth's climate has had some pretty dramatic swings over its history. The level of carbon dioxide in the atmosphere has been thousands of parts per million in the past versus the 420 that it currently is. It's also been as low as about 200 parts per million. And the average temperature has correspondingly been much, much higher and much lower than it currently is. In fact, we're only very relatively recently out of an ice age, a glaciated period. And there have been times in the Earth's history where the entire planet's been covered in ice, we think. What's different about this time is the rate of change of temperature. We have reconstructions of temperature that go back a very long way at different resolutions. We can see almost down to the individual year back a few thousand years, but we can see over decades and centuries. If you're looking back hundreds of millions of years into the past. Maybe not that, maybe over the course of centuries, for example, hundreds of millions of years in the past. And we have not seen a single period where the temperature has changed this rapidly as we're currently seeing. The only times when something close happens is in the aftermath of, for example, an asteroid hitting the Earth at the end of the Cretaceous period. That caused a massive decrease in temperatures. At the end of the Permian period, we saw a big increase in temperatures because of huge volcanic activity. But that took place over millions of years, whereas we're talking about an almost equivalent level of climatic change in a couple of centuries. We are changing the planet hundreds of times faster than it has ever been changed before. And that is the problem. The actual change in temperature isn't so much of a problem. Life on Earth can be very resourceful. It can adapt to these changes, but it cannot adapt this quickly. So yes, we are experiencing changes in climate as we always have. And those natural changes continue to take place. We know that the Earth's orbit is slightly changing and the tilt of the Earth relative to the sun is slightly changing. And that means that we are still moving out of an ice age into this interglacial period. But on top of that, we have this other change that is much more rapid, and it's that speed that is the concern.
Yeah, and you very nicely showed how it's definitely humans causing all, this rapid change. So you talk about carbon in the atmosphere. How about carbon fetching or collection? I know, for instance, in Norway, they talk about this in connection with the oil industry and so on. Do you think there will be in the future a technology that would enable us to fetch this carbon and maybe reverse all the bad effects that we see?
So what we normally refer to as carbon capture or direct air carbon capture is a technology that exists, and it will probably play a minor role in overall how we get to net zero. I actually did a video about this quite recently. There are some industries where it is almost impossible to completely remove fossil fuels. One example is cement. Cement contributes, off the top of my head, about 4% of global emissions. And that's because it's a very energy intense industry. It takes a lot of energy to produce cement, but also the fundamental reaction that goes into making cement, the chemical reaction, releases CO2. And cement is the second most traded commodity in the world. Only water is traded more than cement. So it's a big industry that has CO2 built into it fundamentally. And in that case, carbon capture makes a lot of sense to just keep doing what we're doing before, but capture the carbon that's released from that chemical reaction. It's going to be useful in that kind of industry. It's also going to have limited use when it comes to power generation, capturing carbon, for example, from gas-fired power plants. We anticipate here in the UK, for example, that we will get almost all of our electricity from wind and nuclear and solar, but we will probably have to have a few gas-fired power plants to pick up the demand in what I believe in German is called a Dunkelflaute, which is a period when there's not any wind or and not very much sunshine. And in those cases, sure, you'll probably have to use gas and you'll need carbon capture at that point. The more broad use of capturing carbon and then bury it, because the other thing is you also have to bury it in the ground, is more controversial. Whilst it is possible, it is prohibitively expensive at the moment. A couple of years ago, I did the calculation for this, and if you wanted to try and offset the world's carbon emissions through capturing carbon and then burying it, it would be the same price as buying a new International Space Station every 14 days. It was astonishingly expensive, and it also doesn't get to the root cause of the problem. We know that the root cause of this problem is our dependence on fossil fuels, and just keeping on doing what we're doing and then removing the carbon from the atmosphere does not change the other impacts. We've already heard about the impact of fine particulate matter when it comes to respiratory health, for example. Capturing the carbon isn't going to capture those fine particulates. And as I alluded to earlier, we also now have options that are much cheaper than fossil fuels. We know that we can generate electricity far more cheaply with solar and wind and nuclear than we can with coal specifically. So yes, this technology does already exist and it will probably get cheaper, but it is not the way that we will get ourselves to net zero emissions. The way we'll do that is burning less and less fossil fuels, as will happen economically because of the economics anyway. But yes, this technology does exist. It will probably play a small role in how we will keep the planet habitable. And actually, something that is worth mentioning is that once we do get to net zero emissions, which will probably happen at some point later this century, I would hope personally by sort of 2060, the level of CO2 in the atmosphere will still be very high, and the impact of climate change will continue to persist. The problem doesn't go away just because we've stopped emitting carbon. We will eventually need to bring the CO2 level down, and that means what we call negative emissions, so drawing carbon out of the atmosphere. And mostly we talk about that through natural means, specifically planting more forests, restoring ecosystems so that they can naturally draw down carbon. But it is quite possible that by 2060 or 2070, the technology to suck carbon out of the atmosphere will be much cheaper and will become much more viable. And maybe we will use this technology to start bringing the planet's climate back down to pre-industrial levels. But we would also have to do this relatively slowly in order to let the natural world adapt and not have the same problem that we had increasing the temperature as we did decreasing the temperature. So yes, probably a part of the solution, but it is not the it's not the largest part of it.
When you presented, I was struck by that you are quite positive. You talk about this 2.7 degrees and that we should be able to keep to this. I guess the Paris Accord was 2 degrees, the goal. But then, you have some politicians in some major countries that don't believe in this man-made climate change, and drill, baby, drill is one slogan and so on. But I guess once you get to the point where it makes economic sense, I think maybe that's when things will start to change. And what is your comment on this?
Yes, I mean, I would describe myself as being on the optimistic end of the realistic spectrum. I think there are lots of people who look at the same data as me and are pessimistic. But I see the world has just a huge amount of momentum. This clean energy transition is happening incredibly quickly and is happening faster and faster each year. We just don't tend to hear about the positive news as much. I don't think most people know, for example, that the rate at which we are deploying renewable energy, we are on track, or almost on track, I should say, to triple renewables capacity by the year 2030. It was a hugely ambitious target that was set, and we are almost on track to hit it. Especially when it comes to China, there's this big perception that they are the largest part of the problem and they're not doing anything about it. China is installing twice as many renewables as the rest of the world combined. They are really leading the world when it comes to becoming an electro state rather than a petro state like the Middle East. They are becoming the first superpower that is powered by clean energy. Still not at the moment. They are still very much using coal, but their emissions are, the steps they are taking are just so ambitious and so big. And that is enabling other countries to do the same thing just by sheer quantity of products that they are making. It enabled Pakistan last year, for example, to install 22 gigawatts of solar generation, these enormous numbers. So there is a lot of peril. It is a very dangerous situation. And if we don't accelerate what we are doing, it isn't going to be enough to keep things within sensible, safe limits. But I also believe that if we don't have hope, if we don't think that it is possible, we just accept that we've already lost. And I think there's a great amount of value in believing that something can be done. And one of the reasons I make videos the way that I make my videos is to show people that there is hope. We can still very much control the situation, and we can limit the amount of damage that we do, because it's a cumulative problem. The more carbon we put in the atmosphere, the worse the situation gets. So whatever we do to limit those carbon emissions helps. It makes the future for our children and their children's children better. And so it is absolutely still worth fighting for. It is not a hopeless situation at all.
Well, that was nice to end with these positive notes. Dr. Lichtblau, you talked about infectious diseases. Are there any of these diseases that we can get vaccinated against?
Hal, I think the ones that I mentioned do not have vaccination yet. I think vaccinations are important, and we will, I mean, COVID has been able to spread around the world as fast as we've seen it because of our interconnected world, which is obviously also due to us being able to fly, to burn fossil fuels. So I think it's linked, all of it, with each other, and we vaccinate against COVID. So yes, the simple answer is please get vaccinated as a patient against all the diseases. You will profit. I think everybody will. Obviously, I'm pro-vaccination. You see that. I'm a medical doctor, and but the ones that I mentioned, they do not have vaccines yet. Yeah, maybe if I can ask you a question, because Lucilla and we've discussed this before. Is climate change an important topic for a patient with PH? You know, if you look at the literature and you see or you hear, oh, your life expectancy as a patient with PH is not so good, do you concern yourself with the future of our planet, or is this something that is, you know, a bit further away from your reality as a patient? And how might this change with increasing life expectancy of our patients?
Yeah, for me as a patient, it has been a concern because I noticed this on my body. So I used to go to America in the summertime because I had family there. But then this was on the East Coast. And then the summers just got too hot for me when I got PH. And when we talk about the heat and humidity, to me, it seems like the humidity as a PH patient was especially bad. So I tried a couple of times to be on the west in the US where the temperature was still high, but humidity was not so bad as on the east. And I had much more problems on East Coast. So I just simply had to stop traveling to America during summertime.
Yeah, thank you for your answer.
And this thing about humidity and heat, is this what I experienced? Is this something that there is a natural explanation for, that it's more difficult with humidity than heat for us PH patients?
I think Lucilla can answer this question because it was one of her slides.
Thank you. Yes, for sure. So basically the combination, and Simon, please correct me if I'm saying something stupid, but as far as I understand, the combination of temperature and humidity, basically the wet bulb temperature that you were alluding to earlier, makes the heat bearable or less bearable. And because humans need to perspire, they need to be able to sweat to bring down their temperature. And in PH patients, obviously, the circulatory system is affected. So the ability of the heart to pump blood to the periphery, which is one of the mechanisms of perspiration through vasodilatation, basically the vessels in the hands and feet and in the limbs, they dilate to disperse heat and temperature, and their ability, the ability to do so in PH and in heart failure is reduced. And so it is very logic that if you experience especially humidity and humid heat, you would feel this. I think anybody who's traveled to a tropical country and has gone off the plane and has had that like wall of heat come at you, all of a sudden will know what I'm talking about. And this is basically what happens to you if the temperature goes up in, like, I don't know, 7 or 10 degrees in the space of a night. A young body with a healthy heart, with a healthy circulation might be able to adapt to this much change in a small time. But a heart that has already that is already struggling to pump the blood, and lungs with circulation that is not working very well will be more affected, yes.
Also, we talked about pollution and altitude as being bad for a PH patient. So I guess there's not too much we can do about many things, but when it comes to pollution and altitude, I guess one thing to do is to move to a lower altitude and maybe move to a place with less pollution. Would you say that, would you recommend a PH patient that has problems with this to simply move?
So I can take this question. I think this is not such a simple answer, because we have patients all over the world, and we have patients that are adapted to their environment. Now talking about altitude. So maybe we have listeners from Ecuador, and we've met those patients last year in a study, and they live at 2,800 meters in Quito, and they're adapted to their environment, and they're not fearing worse than patients living at low altitude. And then we also have done studies in the right heart cath where we exposed patients to low oxygen, and we did not see any changes in the pulmonary vasculature. So maybe patients with PH are actually better adapted to live at a bit moderate altitude. I'm not talking about 4 or 5 or whatever thousand of meters. And that's just a question we don't know. And we did studies with patients here in Switzerland where we took them to the mountains just for one day and then for one night, so very short exposure. And we did not see severe side effects. I mean, all the patients tolerated the altitude quite well, and we just gave them oxygen when they hit like a predefined lower level. This was for safety reasons, but not because the patients didn't tolerate the altitude. Same as the patients living at high altitude, they don't necessarily have oxygen. And so I think this is a question where we just don't have the answer yet. And for the pollution, yeah, I don't know if it's so easy to move out of an area of pollution, because usually, you know, you're settled there, you have your family there, or you might also not be financially able to move. And so this is a difficult question. Also, you know, where is high air pollution is also difficult to measure. You might go think, oh, I moved to the countryside because there's a better, you know, polluted, and then suddenly you have wildfires and the air gets really badly polluted. And that's not an easy question to answer. Maybe Lucilla, you raised your hand. You want to add to this? You need to switch on your microphone.
Yes, I knew I was going to do that at one point today. So I just wanted to add that I think there are some things that people can consider when they're thinking about their living arrangements, like where do you want to live? But I really don't think that this is something that should fall on the shoulders of the patients. The responsibility to move away from a polluted area because they have PH, this is not something that a patient can take on top of the diagnosis and dealing with the tests and dealing with their disease. This is something that we need to work on as a community, developing policies to protect vulnerable patients and think of the vulnerable sections of our society and make sure that they are not impacted. I really cannot stress this enough. I don't think this has to fall on the shoulders of the patients. Mona,
maybe to add to that, I think rather than telling people to move away, we should work in making these areas more livable. You know, reducing air pollution should be the goal, not moving away because there's air pollution to create more air pollution somewhere else. There's, I think, a little bit what Lucilla alluded to. I think on the individual level, it's, of course, you can take measures, but in the end, it's us as a community, everyone that needs to make the things happening. And this will be difficult, I think, but Simon is more positive. I think that our community will manage.
You talk about high altitude. Here is a related question to altitude, but not directly related to climate change. And that is PH patients that are flying. Because when you fly, you get reduced amount of oxygen. And I think it's around the altitude of 2,300 meters. and then but then of course it's temporary. And what do you feel about patients flying? And is it very individual, or would you say it's not so bad if the flight is short, or is it okay to fly 6-7 hours across Atlantics and so on?
I think it's an individual decision depending on the oxygen saturation of the patient. So if a patient comes and wants to have advice on this, we usually measure what we can and then make a decision based on the advice. Usually, if we see that a patient has low oxygen levels, we would advise to fly with oxygen for long distance or also short distance, depending on the severity. And if they already are on oxygen, you can just advise to increase the oxygen of the concentrator to be safe while flying. But I mean, in stable patients that are well treated, I don't forbid to fly. I just give advice to use the oxygen if needed. And I have had no patients coming back complaining that the flight didn't go well. And I think this is, you think you fly regularly, and I think you have no problems. And I think this is the experience that most patients share.
Yeah, actually, right after I was diagnosed in 2005, my son, he played basketball on a national level, and he went with his team to play basketball in China. And I really wanted to go and see him play. And I was a little worried about the long plane trip from Norway to China. So I went to and talked to my doctor, and I went to the hospital, and I got a mask, and I was breathing in low oxygen air, and they did testing of blood from my arm to see how the oxygen affected me. And I guess this is a way that you can really test a patient to see if they are capable.
This is a test that you can perform in the clinics. We did this with our altitude studies, where we measured the patients in this test at low altitude and then looked what happened at high altitude, and the results were not correlating. So they were like patients that were with low oxygen in this test fared very well without oxygen at altitude, and the other way around. So this test is not so sensitive, but it can give you a bit of safety. And if this test doesn't perform well, or you don't perform well in this test, you can easily take the oxygen on the airplane with you. I mean, I always say if it doesn't help, it also doesn't cause harm during the flight, right? At least you feel safe when flying as a patient, if you're worried about that.
Yeah, no, the flight went very well. They told me not to move around too much, maybe sit close to the toilet, so I didn't have to walk too far and so
Yeah.
So I see we have a question from Zdenka. How can patient organizations like PHA Europe be included in European environmental or climate policies? I don't know if any can answer that one.
I think you're the best candidate to answer that one. Like, how do your organizations get involved?
Yeah, so we try to be involved on an advocacy level, and we try to talk to people at the EU level. So we are involved at the Brussels level. We do different campaigns there and so on. So I think it's important for us to talk about the effect that pollution and climate change can have on patients like us and all people affected by pulmonary vascular diseases. So I see that we are 10 minutes over time, so I think it's time to round off. And I would just say that it's been a pleasure, and it's been very interesting, and we're going to try to get many people to take part in the survey. And I would like to thank all three of you for being so kind to talk to us today. So thank you so much. And then in about 1 week's time, this recording will be available at the Recorder Studio in the Bel Air Center. And we might in the future also add some dubbing to it. So we use artificial intelligence to make us speak maybe perfect German or perfect Spanish or perfect Chinese. So we'll see which languages we will add. So thank you so much and have a nice evening, everyone.
Thank you for having us.
Goodbye.
Thank you.
Bye-bye.
Thank you.